Acid-base chemistry of amino acids shows up in the chemical and physical foundation section, and it's a classic source of tricky questions. The test doesn't just want you to memorize numbers, it wants you to predict charge states, interpret titration curves, and calculate isoelectric points under pressure. Let's break it down in a way that makes those questions automatic. Ionization basics. Amino acids are amphoteric. They can act as acids or bases. The carboxyl group can lose a proton and become negatively charged. The amino group can gain a proton and become positively charged. That's why their charge shifts depending on the pH. pK values. Two numbers dominate, the carboxyl group pKa around 2 and the amino group pKa around 9 to 10. The R group can add a third pKa if it's acidic or basic. On the MCAT, these values tell you exactly when groups will gain or lose protons. Isoelectric point, Pi. The Pi is the pH where the amino acid has no net charge. For a simple amino acid with no ionizable side chain, take the average of the carboxyl and amino pKa's. Example, glycine has a Pi near 6. This calculation shows up often on test day. Zwitterions. At the isoelectric point, the amino acid exists as a zwitterion. The carboxyl is deprotonated, the amino group is protonated, and the charges cancel. The MCAT loves to test whether you can recognize this neutral state. Titration curves. A titration curve maps how an amino acid's charge changes as you adjust pH. Flat regions show buffering, sharp rises show deprotonation. Each plateau centers around a pKa. Being able to read these graphs is a high-yield skill. Buffering regions. Around each pKa, amino acids resist pH changes because they can donate or accept protons. On the MCAT, this explains why biological systems rely on amino acids to stabilize pH. Side chain acid-base chemistry. Not all amino acids are neutral. Aspartate and glutamate have acidic side chains. Lysine and arginine have basic side chains. Histidine can act as either depending on the environment. These side chains determine protein charge at physiological pH and show up in passage-based enzyme questions. Role in enzyme catalysis. Enzyme active sites often use amino acid side chains as acid or base catalysts. Histidine in particular is a favorite because its pKa is near physiological pH, letting it switch roles easily. The MCAT tests this to see if you can connect structure to function. So remember, amino acids shift charges depending on pH, pKa values tell you where it happens, and the isoelectric point is the balancing act in between. If you can predict protonation states, you'll breeze through many otherwise confusing MCAT passages. With that said, here are just a few of our student success stories. Students who improved their scores and even got into medical school. If you're preparing for the MCAT, click the link below to get started with your own preparation. We specialize in helping students reach a 515+ score guarantee, and we'd love to help you too. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.